Okay, let's continue. So 10 to the hundreds. So where did we stop? 10 to the hundreds. Did we all go here? 10 to the hundreds congruent to 4 mod 7? Did everybody follow this?
No, I don't get it. From 32 mod 7, how did you get 4 mod 7?
Oh, 32 divided by 7 is 4 remainder of 4, right? So
Oh, okay.
yeah. So this is how we get 32 mod 7 congruent to 4 mod 7. So at this point, see 10 to the 10th is congruent to 4. 10 to the hundredth congruent to 4. If you keep doing, it's still be 4, right? You just do it another 10th, it's going to still be 4. So totally you have how many terms? 10 to the 10, 10 to the 100 until what? I forgot the problem. 1, 2, 3, 4, 5, 6, 7, 8, 9. So totally 10 terms, right? So 10 terms, you add all 4. Every term has the congruence of 4. You add them together is going to be 40, right? So let me rewrite in here. So 10 to the 10 plus 10 to the 100 plus 10 to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so this will become congruent to 4 plus 4 plus 4 mod 7. Okay, which is congruent to 40 mod 7. Okay, so what's the remainder? What's the final remainder of this? So 40 and 7.
5.
So 40 divided by 7, 5, 35, 5. Okay, so this is the final remainder. So yeah, you can say this is 5 mod 7, and 5 is the final answer here.
I have a question.
Go ahead.
So you wrote the 10 to the power of 10 plus 10 to the power of 100 plus ... plus 10 to the power of, I'm guessing that's a billion or trillion. How did you get 40 mod 7 from that?
Every term is congruent to 4 mod 7. That's what we concluded, because remember 10 to the 10th? 10 to the 10th is congruent to 4 mod 7. And then we concluded 10 to the 100th is still...
Isn't 10 mod 7 congruent to 3 mod 7, not 4?
No. 10 is congruent to 3 mod 7, but 10 to the 10th is not congruent to 3. After calculation, it's 4.
Okay, thank you.
Yeah, it's 4. How do we calculate? We kind of transform a little bit, right? 10 to the 10th become 3 to the 10th, become 9 to the 5th, and become 2 to the 5th, which is 32. 32 become 4. And similarly, when you do the 10 to the 10th, you do another 10th. What we found, this become 4. You just keep doing 10th. It doesn't matter how many 10ths you did, as long as it's another 10th, it's still 4. It's going to be 4 again. Why? Because 4 to the 10th is congruent to 4 mod 7. Okay, so this is the beauty of the modular. And if you look at this complicated math problem and using modular property, it greatly simplified it and make it possible to get worked out. Okay. Yeah, spend some time offline. Hopefully we recorded everything and get really run your brain muscle for this. I think all the rest are pretty good. And oh, what is this? 35. 35. What is 35 here?
It's the quadratic inequality.
Okay, yeah. Don't worry about that one, because I haven't covered the knowledge yet. Let me try to do it today, okay? Let's see. I think we are doing fairly well for the rest. Okay, I'll cover that today. All right, pretty good job, I think, the last two meetings. Thank you for working on this. Modular, you can see, is it's a very targeted problem. Sometimes you see one, make sure you do it right. And very briefly, oh, actually, am I sharing? Yes. Okay, let's do it. So this meeting, I don't think there's a lot of knowledge to cover, but it's more like on meeting progress exercise for everyone. Okay, and I just look at briefly review what happened last time, and today let me start with algebra with integers. It became a targeted knowledge late in recent years. So I kind of summarized the things you need to know in here, and the top three are probably the most important formula you need to know. So a squared minus b squared equals a plus b times a minus b. You need to know both ways, okay? You need to know how to get from here to here and here to here. And the second one, there's really nothing to talk about here. You just need to memorize it. You have to memorize it, okay? You can't say, okay, I can derive it, but that's not good enough. You need to get to this right away, okay? A plus b squared is a squared plus b squared plus 2ab, and vice versa. And if it's a minus b, it's basically the same thing. If you know the positive, you should know the negative, right? It's just plus negative b here. You replace b with negative b, so the square part still remain, but the 2ab part becomes negative 2ab, okay? And from time to time, we will need to use this. It's not very frequent, but when the time comes, you don't know, it kind of suck, right? I would say there's maybe 10-15% of time you will need to use this. So if you can memorize this, that'd be great. If not, at least you need to know how to derive it, okay? All right, for example, we're gonna solve this. Why don't you all start doing this? Should be done within 30 seconds. Get it right, okay? I think you know which formula to use, but get it right. All right, what's the answer? Anyone?
240,000.
24 and 5 zeros.
Oh wait, yeah.
How many zeros?
2,000,000 for
Okay,
2,000,000
just
for
say the digit and how many zero.
24 and 5 zeros.
Perfect. Okay, 1, 2, 3, 4, 5. Actually, 6 zeros. Oh, am I wrong? 1, 2, 3, 4, 5. Okay. Yeah, the answer is wrong. Sorry, you're right. 24 with 50 is correct. Okay, so that's what we use, right? The first formula. because when you add them together, it become 4 with 50. You minus them is 6. So 4 times 6, 24 with 50. Okay, good job. All right, so next one. Now let's start working on this. Let's give 1 minute for this one.
Oh, could you go back to the old screen? Because I kind of want to copy it so I can use it later.
The slides will be made available in website. If you want to take a snapshot, that's fine too. Okay, take a snapshot. Okay, ready? Let's go. Oh, you mean, yeah, that's a good idea. Take a snapshot if you need. Now let's look at this on 1 minute. Okay, that's it. So at least everybody will read the problem, right? You understand what this problem wants. Okay. Due to time limit, I'm gonna start. Just talk about it.
2003.
No, that has zeros. That has
2003?
zeros.
No. It can't be
Yeah,
2000.
zeros. It cannot
Oh,
have
right.
any zeros.
I'm not sharing anymore, right?
No.
Okay. Now, okay. What Sarah just mentioned is correct because we want a product to be greater than sum. So if there's any zero, it won't happen, right? It won't be possible answer. So we're gonna start from 2, 1, 1, x. Make sense? It can't be 0, and x cannot be 0, right? Everybody, follow me, okay? So now we want what? 2 times 1 times 1 times x, which is 2x, right? It needs to be greater than 2 plus 1 plus 1, 2 plus 1 plus 1 plus x. And this part is 4 plus x, right? So we want 2x greater than 4 plus x. So when we solve the inequality, this is follow the same rule of solving equation, okay? So we're solving 2x greater than 4 plus x, okay? Let's follow the same rule, okay? So you can just say minus x on both sides. So x greater than 4. So you just minus x on both sides, okay? So the very first year, the product is greater than sum is 2115. Make sense? If it doesn't make sense, you need to tell me now, okay? I only leave like 20 seconds for you to tell me. And it's also the answer is written here. So essentially we're trying to make a good guess first, right? Because at first this problem seems to be impossible to solve, but then you think about it, the very first year will be 2000, a bunch of 0, okay? It's not possible. So we're starting from 211A, and fortunately this work out, okay? It worked out just fine. But sometimes 1 doesn't work. What do? You're gonna start with 212, right? Trying just to make another digit on the least significant bit. Okay, and move on. Let's work on this one. 1 minute. Give 2 minutes actually, because I want you to actually figure out the final answer for this one. Okay, do we have any volunteers on this one? Okay, Matthew, go ahead.
Do you mean me?
Yes, you.
Oh, okay. Great. So we know that like any three adjacent numbers is 18. Their sum is 18. So we can just directly divide 18 by 3 and we get 6. So we know that like every three adjacent numbers, if all of them had values of 6, it doesn't matter like which combination we have, like B, C, D, E, A, G, like at the end it'll always be 18. So
What is the value of h you got?
6.
That's incorrect, unfortunately. I think the way you're dividing it, that doesn't match what I have. It shouldn't be division here. But thank you for speaking up for it. Anyone else have any idea on this?
Yeah.
Okay, go ahead.
Since 3 and 8 are already listed, it has to be either, it has to have 3 and 8 as a sum. So 15 minus 3 plus 8 is 7. I mean, it's 18 minus 3 plus 8 is 7.
What's your final answer of h?
7.
Okay. Now tell me how do you get it? If it's wrong, I don't have to. Okay.
Because 3 and 8, like if they have to be in the 18 sum, so 7 has to be the other answer, and if
7 has to be other answer. Why?
because if it's not, then any random number, any three random numbers wouldn't add up to 18. It has
Okay.
to have a 7, an 8, and a 3.
If it's adjacent, yes, but 3 and 8 are not adjacent. It says 3 adjacent numbers are 18. How do you convince me that's 7?
Because you put B, C, D, like if you do 3, 8, 3, 4, and then 3, 8, 3, 4, the 8, 3, 4 would be 15, not 18. And same with anything else, except for 7. It has to have 3 numbers.
Hey, Sarah, I don't know how you get it. Maybe you can tell me after meeting. But here's how this problem should be. Okay. Now we start from the known number. Yes, that's correct. But we're gonna start from how to say the adjacent 3, right? So for example, EHG is 18, and then 8GH. So the 8GH is also 18, but they share 8G, right? So E and I must be equal, right? Sorry, E and H. Sorry, it's H. Yeah. So E and H must be equal. Everybody follow this? Every 3 are adjacent, are equal, and they share the 2. So H and E must be equal, right? So now we just look at this part. So this is this next known number, right? So 3BC and BCD, they must be equal. So D must be 3. Yeah, I see a lot of people raise hand. So D must be 3. And then, okay, bingo. We look at this 3. We have 3, 8, E, right? 3, 8 is 11, so E must be 7, right? And then E is equal to H, so we know H is 7. We always work on the ones that we know, and then we're trying to kind of derive back and just see, get figure out the number along the way using the condition, okay? And sooner or later you derive the final answers, okay? Okay, we'll continue. Okay, have the answer here, okay? All right, next one. Let's do 1 minute at most. Pretty straightforward, right? Just compared to the previous one. I just want to tell you that the real problem does not have the A and B. The real problem in competition is just C. It asks you, what is the sum of two distinct positive integers whose squares differ by 49? That's it. And this A and B is added for you to build up the thought. So at least the expectation for all you guys is, with this kind of intermediate hint, you need to get to the answer pretty fast. Okay, any volunteer? I'm gonna call someone that I know. If no one is volunteering, let's see. Maybe someone that hasn't spoken that much. Jack. Jack, you here? Jack He. No? Okay, let's try Sylvia. Is Sylvia here? And what about Chloe? I'm keep calling until I got a response. Oops. Okay, I lost my. Okay. Michelle.
I'm not really sure.
Is that Chloe or Michelle?
Michelle.
Oh, okay. Thank you. Is Sparsh here?
Yes.
Can you help us?
I'm not really sure.
No?
No.
I have an idea how to do it.
What about the A? Factor the expression A squared minus B squared. Can you get this part?
Yeah, A plus B times A minus B.
Yeah. Well, maybe we didn't spend time to memorize the formulating here. But I kind of expect this is already introduced in 6th grade. Is that correct? But of course, for 6th grader, this will be maybe still new. Okay. Okay, so let's go back to here. Yeah, so a squared minus b squared is a plus b, a minus b. And what's the two distinct positive integer that can have a product of 49?
1 and 49.
1 and 49. Right?
Yes.
Yeah. Yeah. And that's the only one. That's the only answer, right? Because we know you need to have some square minus another square equals to 49. And happen to be 1 and 49. Okay. And okay, what is the sum of the two whose square differ by 49? Let's just follow the B.
Sir C, is it 5 and 8? Or no, wait, it's 13.
Differs by 49. Yep. Okay. Just to add a little bit, yeah, I appreciate whoever spoke in there. A square minus b square is a plus b or a minus b. And for specifically for 49, it has 1, 7, 7, 49, right? So that's the only possibility to get to that would be 49 and 1. Otherwise, you got two not distinct positive integer anymore. And therefore, one of them would be 1, and when the other one will be 49. So, and when you solve this equation, you get let's solve it. I didn't put it in here.
Your audio kind of messy.
So one of them is 25, the other is 24, right? So you add them together is still 49. Okay. Let's move on here. So we got another warning. It's gonna end pretty soon. So 2-digit number, 3 times the sum of digits. Okay, let's give 2 minutes. I expect a lot of people to figure this out, okay?
I have a question.
Yep.
For
Well,
the
everybody else can focus on your problem solving while I answer the question, okay? Go ahead.
for the math counts textbook, is it online or are we gonna get it in person sometime?
There's no textbook really for students at this point. This is really
So then what is math counts? It said in the slideshow with on the first meeting, we're gonna receive a textbook.
no, it's only possible for coach to have a textbook, but yeah, not for students. But you know, I can if you want to have a book to work on, I can make some recommendation. The AOPS introduction series are pretty useful, and that's a lot of problems are based on that. Introduction to number theory. You know what? Let me send an email to everyone. If you're interested, you can purchase them and just learn by self. But I don't really follow strictly a textbook. And
Hi, I'm sorry, but someone keeps kicking me out of the meeting. It's been happening from the last 2 times now.
yes, because we hit the 40 minutes limit. Once you see that, just dial in right back. It's because we're using free Zoom that has this limit. Sorry about that. Okay, let's go back to here. Anyone get the answer for this problem? Anyone?
Is it 27?
It's 27, yes. How do you get it? Can you speak your name?
Monet?
Mane, thank you. How do you get 27? Can you please tell me?
Well, I tried 25 first and kept going from 25, and I arrived at 27. 2 plus 7 equals 9 times 3, which is 27, the digit that we started with.
Good. I mean, that's a valid method. Just try and error, and that's what we need in competition. But there's also a standard way to solve this, because this whole thing is called algebra with
Also,
integer.
the number has to be divisible by 3 in order for it to work.
Yes, that's a very smart guess. Okay, so due to time limit, so we have a 2-digit number. Let's say the 2-digit number is AB, okay? This is the 10th digit, this is the unit digit, okay? And per the problem, we want to know that the 2-digit number itself is actually 3 times of the sum of its digit. So we know sum of digits would be 3a plus b, right? But how do we express the number itself so that we
10A
can make an equation?
10a plus b.
10a plus b, thank you. So 10a plus b equals 3a plus b. So this becomes a equation with 2 variables, right? Don't worry, you won't get a final solution for 2 variables in one equation. However, because it's a digit, there's a lot of limits, right? So let's try to simplify this, okay? So 10a plus b equals 3a plus 3b, right? So let's subtract 3a on both sides. We got 7a in here, and subtract b again, so b is gone. So this is gone, this becomes 2b. Okay, so 7a equals 2b. Right, this means what? What does this mean mathematically here? 7a equals 2b. Anyone? It means b must be a multiple of 7. Yeah. Yeah. Thank you. Yeah. Because and then a must be multiple of 2, right? That's
2.
just what it means. Yeah. So when b is multiple of 7, there's only one possibility for b, right? B must be 7, right? It's a single digit. And then 2, 7, 14. So a equals to 2. All right. This is how we mathematically solve this problem. But Manet's solution is definitely valid. You start with something, you get to the answer. That's all we need. Okay. All right. I think we're going to be kicked out very soon. So some warning in there. Okay. Now let's continue. Yeah, we're just going to keep doing the exercise, and a lot of portion of this club is to introduce the problem to you, introduce the trick to solve equation, to solve problem, and so that you can be familiar with the computation. Okay, let's.
You keep on mentioning this competition. Will it be in person or virtual?
I lost your audio, the critical part. So repeat the question.
Will you keep on mentioning this competition? Will it be in person or virtual?
I think it's going to be virtual this year, but I'm not 100% sure yet. I think it's going to be pretty close to what we have last year, which is virtual. I think it's going to be virtual because Black Mountain School is not allowing us to meet. So even I have a hard copy of it, the exam or computation, we probably don't have a place to sit together. So it's going to be virtual. One of the coach will proctor the test. Okay. Yeah, the reason I keep mentioning competition is because that's an important goal. That's something that tells us in a solid way how we're doing. And it doesn't mean a lot, it doesn't mean 100%, but it's one effective way to tell us how we're doing in math. So that's, yeah. All right, this problem, still the real problem is just on C, okay? There's no step A and B, and the A and B were added to give you some hint. The real problem is what's the sum of all possible value of X if X and Y are positive integers with this. And A and B will give you some intermediate steps. $707. Maybe we should wait until it kicked us out. It could be happening very soon. Keep working on it. Yeah, I think that's enough time. Any volunteer for this one? Sorry, I don't have
Is
a
the
lot
answer
of-
14?
It's the answer 14. I don't remember, but why don't you start talking us through